How are capacitor lifespans measured in hours? I'm looking for the marketing information for my motherboard, and noticed an odd statement regarding the lifespan of their Nichicon 12K black caps. Supreme 12K black capacitors with lifespans of at least 12,000 hours, emphasis added. Compared to other counterparts on high-end motherboards that merely have lifespans of around 10,000 hours, ASRock applied Nichicon 12K black caps that offer 20% longer lifespans and provide more stability and reliability. Source: 12,000 hours equals 500 days equals 1.37 years. This can't mean that the total power down time for the PC is expected to be less than a year and a half, can it? It certainly wouldn't be something I prominently highlight in my marketing material.
I'm not an expert in this area, but look at available info. Lifespan is temperature related. Life actual equals life base times temperature factor times voltage factor times current factor. Life actual is the life expectancy at the operating temperature, voltage, and current. Life base is the life expectancy at the rated temperature, voltage, and current temperature factor. For both LE caps and film capacitors, a 10 decrease in temperature results in a doubling of life expectancy. So the temperature factor is 0.1 Tm minus Tc. Where Tm is the rated temp and Tc is the operating temp. Voltage factor is the derating due to the operating voltage being lower than the maximum rated voltage. According to United Chemicon, voltage has far less of an effect than temperature on the lifespan of an LE cap, unless the voltage is exceeding the rated maximum. Current factor is the derating due to the operating current being lower than the maximum rated current. Current has a more significant effect on LE caps than film capacitors because of their higher equivalent series resistance, ESR. The power loss due to the ESR will be equal to I2 capacitor, and all of this power loss leads to self-heating, which will affect lifespan. Voltage and current related. Calculating the lifespan of electrolytic capacitors with derating. So based on it you can multiply lifespan in times 4x, 8x. And avoid overheat. Cool PC, long living PC. But really, capacitor is one of most dying components.
This is an attempt at marketing that fails due to oversimplifying an engineering issue until it actually means the opposite of what it's supposed to mean. And this question is all over the internet. As explained by the others, capacitor lifetime depends on temperature. I picked a random datasheet, Nichicon 5, this is the endurance spec. This means the manufacturer guarantees that after a number of hours at a specific temperature, the important specs, capacitance and ISR, will not degrade by more than -20% and +50% respectively. It doesn't mean the cap pops off or stops working completely, it simply degrades. If the application does not require the full performance of the capacitor, then it may work fine for a much longer time. For PC mobos this is not the case. High performance caps are required on CPU VRM, especially ultra-low ISR due to the huge ripple currents involved. ISR is equivalent series resistance, and it will increase as the capacitor gets old or if the electrolyte dries out, which makes the capacitor heat more, due to resistive losses, and perform worse at its apply voltage smoothing role. This is different from the well-known capacitor plague, which was due to a faulty electrolyte formula. In this case the capacitors did not honor their lifetime specifications, they were defective products which are no longer manufactured. Now, alu polymer caps rated for 12K hours at 105 degrees Celsius are very good quality components, some of the best available. Usually you would get 2K hours 105 degrees Celsius caps, so ASRock is selling a good product with dumb marketing. However, it doesn't matter at all. Using the lifetime estimation from Illinois capacitors that Tim posted, At 60 degrees Celsius, which is already very hot for a MOBO, time to clean the dust, the polymer 2000 hours/105 degrees Celsius cap would last 40 years already, and the 12,000 hours cap would last 2 centuries. Temperature has a huge influence. So, yeah, the 12K hour caps are a nice touch, but they're a bit of a luxury. 2K hour 105 degrees Celsius caps would still work fine when the computer becomes obsolete and is replaced. Especially since the 60 degrees Celsius temp I used is quite pessimistic, the caps should be much cooler than this unless you run high CPU load 24/7 and the airflow is terrible. So, no planned obsolescence here. The caps that are accused of planned obsolescence and die are usually the ones which are inside consumer electronics power supplies, right next to a very hot heatsink with low airflow. They run close to max spec and aren't polymer caps but rather low ZLU electrolytics which are more vulnerable to heat. If the manufacturer puts a Crapson brand 85 degrees Celsius rated cap in there, yeah, it's gonna go planned obsolescence pretty quick. Also the caps on the HDMI board in a Buddy's AV receiver, all 85 degrees Celsius caps next to a big hot CPU with no fan and no airflow. This receiver is famous for this, all the caps always die. This is more of a design mistake or excessive cost cut than planned obsolescence though.
This really depends on the type of capacitor, and there are many factors involved. Max temperature rating. Ambient temperature rated voltage, in volts DC applied voltage, in volts DC rated ripple current, milliamps/amps applied ripple current, milliamps/A part rated with ripple, percentage. Each individual type of capacitor is measured differently. Radial, SMD, snap-in. Polymer type capacitors. Supercapacitors. Axial aluminum electrolytic type capacitors. Film type capacitors. The operating conditions affect the life of a film capacitor in a close way to aluminum electrolytic capacitors. Voltage derating has a greater effect on the life as compared to an aluminum electrolytic capacitor. Ceramic type capacitors. Planned obsolescence, or built-in obsolescence, in industrial design and economics is a policy of planning or designing a product with an artificially limited useful life, so it will become obsolete, that is, unfashionable or no longer functional, after a certain period of time. The rationale behind the strategy is to generate long-term sales volume by reducing the time between repeat purchases, referred to as shortening the replacement cycle. The company advertising that 12,000 hour rating just may be a case of planned obsolescence, or built-in obsolescence. I would want to blame the design engineers, but I am sure it wasn't even their fault. Companies seem to have no shame at all anymore engaging in this behavior, and it doesn't seem to me like a good business plan to advertise you are essentially shortening the replacement cycle. References. This URL. Equations taken from IllinoisCapacitors.com, where you can also find nifty calculators for the equations mentioned above. This URL.
I don't know what the specs of those exact capacitors are, but research has shown it is also temperature related. It's 12K at a specific temperature, and the lower the operating temperature is compared to the rated temperature, the longer they will last. Cheap capacitors can be rated at 50C or less, and good 170C possibly more. 50C can be a real problem as the case isn't properly ventilated. If you have a house without air conditioning, your case is crammed into a poorly ventilated area, and the airflow in case is bad.
If you want to support the channel, please consider subscribing.